lab. And if it is possible, you had better use the computer, right here in the computer, because we have a broadcasting system, so I can broadcast the desktop or the student's computer to your terminal. So that will be easier for you, to follow up the lab instruction. Okay. So take a look at you. I think it's for you in here, because this is the teacher's computer. So I have a teacher size program, and what you have probably a student size application. So try to get familiar with that a little bit. Okay. So usually I will control all this broadcasting. From the teacher's side. So did you see the check? Did you have in your terminal? Did you have this picture? Yeah. Okay. So most of you see if not, probably you need to manually activate the student size application. So take a look at your desktop. Probably you will have application icon there saying that should be a student size application. So click on it. So make sure you can join this broadcasting system. So from time to time, I will use screen broadcast or Windows broadcasting. So this mode is Windows broadcasting. So you can shrink the teacher's desktop into a Windows, right? So that will be. Let me check. Yeah, right now it's Windows mode broadcasting. So you can you can see the teacher's desktop in a window. So that will be much easier for you to follow up the instruction. So sometimes if you have a problem, I can. Excuse me. Kind of hung up. Okay, it is back. I'm sorry, it does not work. It's probably it is hung up somewhere, or probably too many students has connected. Let me restart it. I think something wrong with this. I'm sorry, I think our broadcasting system does not work well. So I don't know why. Kind of hung up there. Okay, I think our broadcasting system is somehow failed, so it's really troublesome for us. I think what we have is probably just the LCD projection. Okay, so let me see. Okay, this is the assignment sheet we have. I mean, up to this point. And I'd like to add something if you do not have any particular problem, because so far, I mean, it's so premature, right? I do give you a demo application that should be complete by assignment 6. So step by step, we will need to add a lot of function about fuzzy inference system creation and inferencing. So step by step, you need to add all this functionality to the current assignment. So make sure you did not lose it somehow. I mean, during this assignment implementation. So this one will be the final one. I mean, once you complete assignment 6. So right now we kind of work on this part, right? We add a universe. So later on you will extend your tree view to accept the default label. The first label should be category, telling the user that the user try to add an input universe. Okay, so usually input universe can be multiple, right? So the second one, and if the user click on the output universe later on, I mean, just one universe can be defined, no more. See, no more universe can be specified by the user because we just have one output universe can be defined. But for the input universe, the user can keep adding it, subtract it somehow later on. You can do that yourself. So today I'd like to probably, I mean, instruct you because the user's terminal might be very large, so we like to take advantage of a larger screen. So you will let your control can be expand or shrink it, expanded by the user. Somehow, so we need to get familiar with this kind of user interface. So I will show you probably later. So far, we just try to set up this user interface, right? We have property shown up, so this is X1's property. So we let the user, I mean, change the parameter right here, the parameter right here. And initially, user should define the primary fuzzy set via this user interface. So we have a list. It's a combo box, which is pretty similar to the list box we have been using before. So get yourself familiar with all kind of user interface that will help you design user-friendly user interface. Just feel free to try them. What I instruct you just the methodology or the steps. You can access them, and then later you need to have a passion, try to learn everything, try to use everything. Okay, that will help you elevate your ability to design a good user interface somehow. So remember that you have a bunch of fuzzy sets needed to define it. Remember, I did not ask you to do the trapezoid, but definitely trapezoid is frequently used in inference system. So user select the kind of fuzzy set, and then by clicking on a universe, so the system knowing that user try to add a fuzzy set on this universe, right? If user click on another one, define on the second one, and pay attention to the legend. You see, what you have, all your legend has been grouped up within one group, right? You need to find it out by yourself. I mean, in order to make a consistent legend somehow, just just try a little more time. I mean, play around with the chart, because a lot of settings can be done there, or programming done by your program. So make sure they are consistent, because this pair is defined on this chart area, right? So the legend should be appear right here, not just group them together, I mean, in another place. All right, try to do that. And if you click on, if a user click on a fuzzy set, right, try to do something, this button has been graded out. So pay attention to this kind of foolproof mechanism. Don't let the user, I mean, trapped during the modeling construction, okay? Because you know it is not legal right now, because user specify a fuzzy set. We are not going to add a fuzzy set on this fuzzy set, right? Only click on universe, then this button is enabled. So try to think about this kind of logic to let the user, I mean, well, what we usually call is a user-friendly user interface. Okay. All right. So what we would like to have for the assignment 3 is up to this point. Just user can add a fuzzy set somehow there. Okay. Is there any problem about that? So as you can see, I have added another label right here. So just pop out the name. So knowing that user knowing that he is doing the parameter change right here. And take a close look at this property style. Oh, okay. This property, right? We kind of familiar with that, because in design phase, in user interface design phase, we have been using that to specify the outlook or user interface, right? So there are two kind of option: alphabetic arrange. There is no any category associated with each parameter, right? But somehow, well, if user click on this guy, this parameter has been grouped, right? Grouped within a category. If you do not specify, well, the category is others right here. But we know, I mean, during this, when you design a class, a fuzzy set class, you have defined a bunch of properties so that the user can modify or just set it, read only. You see, if it is grayed out, that means it's read only, not settable, not updated by the user. If the user can update it, then it will appear here. But we like to group it. So we still have several property. I have not characteristic. I have not teach you how to do that. So just take a look at this demo application. Try to achieve, I mean, what you have, and especially for you see, for those, I mean, who are familiar with C# programming, you should try this. Okay, we know. If we like to change the parameter, user may come here, type maybe fine, it's okay. But how about this one? Well, we have a kind of control point there. So user can drag it. Once user drag it, you see the parameter changes too. So this kind of, I mean, advanced feature actually can be achieved. Okay, so what if? But don't worry about, I mean, don't spend too much time on this one, okay, because that is kind of advanced. What we like to have is that we have a property grid, so user can easily specify a new value for it. And how about the initialization? If I kind of here, I specify the Bell function, right? Bell function. So in universe one, if I click on one, okay, it's a default one, right? How about I add another Bell function? You see, this is not the case you have, right? I kind of, even though it's initialized with default value, but it's different, right? But in this moment, we always use the same default value, right? I mean, in our constructor. So if you would like to have a very user-friendly user interface, you should randomly change the parameter, right? To let the user know that, oh, okay. Otherwise, the user will not see multiple Bell function has been created, because what users see is just the same one. I mean, actually, we have multiple, I mean, Bell function hidden behind the first one. Okay, so try to make your code, I mean, much more, I mean, well, friendly anyway to the user. Okay, so how can we do that? Well, let me so let us anyway, just let us continue with our assignment 3. Okay, so if you have, okay, let me try once more to see the forecasting system is working or not. If I broadcast it in the Windows style, did you get a Windows? Okay, so now you can follow it. I mean, you don't need to turn your head, I mean, into the screen. So that will be much easier for you. All right, so this is our assignment 3, right? So let me show you, I mean, how can you achieve this kind of random initialization for your fuzzy set. So what I have implemented just Gaussian fuzzy set, right? So probably up to this point, we have implemented several different fuzzy sets for it. So it's okay. So remember that our Gaussian fuzzy set, we do have static data. I mean, try to update it each time when user instantiate an object or Gaussian fuzzy set, so we can use different kind of to name it. So take a look at our constructor. So this is our constructor, right? So everything has been fixed there. So if user click 5 times, then 5 fuzzy instances will be overlapped together. User may not see it. So we have better set a random value for it, right? So how can you do that? Well, remember that U is universe, right? So once you get the reference of U, you can access the value. We do have a minima value, right? Minima value. And we do have a U maxima value. So if you like your the center of your Gaussian fuzzy set remain within this universe, it's very easy. You can just check the universe BR. But we need to have a random number generator. So we do have a random number generator. But in here, because this is a Gaussian fuzzy set, inherit from the genetic fuzzy set, right? So if you want to go to the definition of genetic fuzzy set, double click on it, right click your button, and move to definition. Okay, I'm sorry, I mean, because the current is Chinese interface, so later on I will switch it back. So we came to this file, genetic fuzzy set. So we kind of try to define a random number generator shared by all the children, shared by all the objects of the genetic fuzzy set. So it's the place, I mean, we put on the superclass or the fuzzy set. So maybe we like to have random. Random is a class, dynamic framework class. It is used to generate random number, but you need to instantiate an object. Because probably in your application, you might have multiple random number generator using different kind of seed. Well, a random number generator actually generates a series of pseudo random number according to a formula. So if you specify different kind of seed value, then it will generate different kind of series of random numbers. So probably we call it shared. Maybe call it shared RND random number generator or random. So the naming is not good enough. Okay, but never mind. So we can within the class we kind of add a data field, right? So we can instantiate right in the definition of this data. So random number have two constructors for you. So if I did not specify any seed, it will use the current time tick somehow, I mean, to do the initialization. Or otherwise, you can specify a certain kind of value or the seed. If you specify the seed to a fixed or constant value, then that generator will generate the same series of random number. So right now we have a shared random number, but by default the accessibility is private. It's private. So right now shared RND can be used within within this genetic file set, not the derived class at all. So usually if you, like your children or grandchildren have the same accessibility, you need to declare that as protected. And if it did not specify anything, that means every object have an object of shared random number. But it is not necessary, right? Because we just want to arbitrarily get a random number. So we declare that as static. Meaning what? Meaning just one object is created by the computer and shared by all the derived class. So right now we have shared RND can be used. So let's go back to the Gaussian file to say, okay, I like to set the center randomly, right? So in this case, I can try to access that shared. See, once I type sh, IntelliSense has sense, right? Well, this guy can be used. This is an object name. And you had better spend a little more time to check the usage of this random class. How can you check the reference? Double click on it. Press F1 key. F1 key is, by default, F1 key has been used in all the application. By default, it is treated as a help key. Help key. If you do have any problem, you hit the F1 key. No matter what kind of application you are using, okay? So right now we are using Visual Studio. We do have a F1 key can be used. So if your computer is internet networked, then it will pop out the web pages related to this random class. Nothing happened. Okay, right here. This is my browser, right? So random class has been fine for you. So you can check about the usage of this random class, and you can see a bunch of C# Visual Basic sample for you. And you can check all the popular function or property, anything there. So once you have a problem, highlight it, press F1 key. It will help you. So right now we like to let the user have a random center, right? So we ask this guy, and usually if it is related to the real number, so there is a function called next. Next double. Next double. So next double will generate a random number. The value range should start from 0.0 up to 1.0, not included. So take a look at this function. All right, there is Chinese there. Okay. 大于或等于 0.0， 但是小于 0.0 的 random number. So once you get this number, how can you do that? So we will type what? U dot max, right? Minus U, excuse me. So we will keep using our universe, right? Universe do provide this kind of property. So this time we can use it right here, minima value, right? Type it. Plus what? Plus U minima. So we will have random number generated, amazing, for our center. Okay, so you can do the similar work for the standard deviation somehow, and you try to make your code, make the generation. I mean, have a different kind of center. I mean, let the user knowing that. So through this change, user add a Gaussian function, add another Gaussian function. Excuse me, add another function Gaussian. What? It does not work. Something wrong, right? Okay, let me see. Share the numbers. A maxima minus minima. If something weird, right? So why not just set a breakpoint? So since most of you are the newcomer for C# programming language, so you have better, I mean, from time to time, set up a debugging mode, check the value. Nothing is called, right? This control is never called, right? Is why they remain the same. So what is the problem? Interesting. What's wrong? Okay, let me. Okay, again, there is a command called clean. Don't worry, it is not delete. Clean, just clean up the intermediate artifact created by the compiler. So I'll try to recompile my code again. Okay, debug it. Create file set. Interesting. So again, I cannot find the problem. So start from where? Okay, start from this button click, right? So double click it and set a breakpoint. Try to see if everything's fine. We came here, we came to here, right? So F10 key, step. If you press the F10 key, then it will be executed step by step. So we will try enter this constructor. So we press F11 key. Interesting. So it is not combined with this file. That means the file list within this project somehow is gone. Okay. I need to clean up on my project somehow because the code cannot. All right, my project is right here. Assignment 3. Assignment 3. Okay, the problem came out from the path inconsistent. Okay, let me see my file set property user desktop. Seems okay. Are you guys okay with your project? I mean, by adding this random number, if it is okay, then I don't want to spend much more time on that. All right, so but I needed to make it work somehow. Okay, let me take a shortcut. Let me close this solution and open a project. Kind of stuff on project. Directly, I mean, pick up the C# project, and let me see if I can make it work well or not. It's kind of weird. I don't know whether the problem came up from Visual Studio or my project. My project should be okay. Probably Visual Studio have some do it. Can you guys? I mean, anyone can give me your project, your assignment so far project? I can use your project. Try to see. I mean, if I can make it work well or not. 有没有人可以？你现在做的差不多了，你就给老师一份那个母子碟，我用你的专案来引导大家哈，加上其他的功能，可以吗？不要紧张，不用说一定要完备的，只是主要老师要跟大家加一些东西，可以吗？那个东西给我。我在担心Probably the problem came out from the Visual Studio installation, so I don't know. Because I cannot debug it somehow, so. 可以吗？可以，哪个同学准备一份给我？他正在弄。好，好，谢谢。好。It seems the problem came out from the debugger. Debugger cannot access the file. If the problem came out from the Visual Studio, I cannot do anything to that. So for the rest of your say you can use that shared random number generator to provide different initial parameter for each instantiation. Okay, so that will let you use see the different kind of different Gaussian file that has been created. So later on he can retrieve it, the particular file set for parameter changing.
哎，这个吧。然后或者
这个吧。
哎，这个是这个对。
是的。好。OK。
可是我没有做的很完整。
不要紧，你知道，哎，这样有旁边再讲。我还没学这边debug那个 work， 那个 work 要看环境没有设，说不定。好，可以，好。Oops。Alright, Gaussian for this. Great. Okay, so we have. How about the second one? If I add another one, great. This has accomplished this kind of functionality. So it's okay. I mean, it's great. I mean, all right. So right now, user can experience a new Gaussian function has been added, right? Because arbitrary random number has been provided for the parameter. So that is the one I'd like to have. So the next step is over here. You see, we have defined few property there, but by default they have been grouped in category called others. So we might like to categorize our parameter into different kind of category. So how can we do that? Well, you need to add a step called, well, let me see. Let me make sure the debugging is working. Yeah. Great. Okay. So it's working. Yeah. Error file set. Oh, excuse me. So you see, I'm a user. If I use this kind of application, sometimes I'm confused. So try to hide some button. When it is ready, then you enable it. Today, to let your user, feel free, once you click on something, then definitely something will work, not just does not work. See, if I click on U1, I try to, oh, okay, there's about the error for this, right? Click it. When I click it, nothing happened. So the problem is that by default, that is why I'm saying that you usually set up a default selection. So if initially your CompBox has a default selection, then definitely user click on this button, it will get Gaussian function. Okay, so our debugging is working. So the problem came out from my project, not from the Visual Studio. Great. All right, so how can we do that? So take a look at your Gaussian function set. Right now we have a property defined right here. So this is not part of the code, right? We call it a directory command. So we set up within our source code because it will be lengthy. So we add a region. So how can you do that? Maybe I have shown you last time. I don't need to do that again. So we have property category right here. So in front of your definition of your property, you can add a so-called attribute. Try to add some decoration message to decorate your property. So later on, when the property is pop out in the property grid, it will be categorized somehow. So I will try to follow that. If you want to add an attribute, it is included in the pair of right angles. So we add the start attribute name. The attribute is called category. And initially it is not recognized because category is, you can say it is a class, another class defined in .NET Framework. Right now we did not use the namespace, so it is not recognized. But don't worry, once you type the keyword correctly, category, then you move to your cursor here using system.component.model. So this attribute class has been defined within this namespace, system.component.model. So category, and then right now it is your responsibility to name the category. So we might call it, okay, this means it's related to the parameters. You can type Chinese category, is okay. Parameters. Excuse me. A parameter, right? You see, I have a purple curly line came out, right? Because I have installed spell checking. Right, parameters. So you can copy it. That will be much easier for you. So I add it to a standard deviation. So I have added two property to my Gaussian function, right? This property. I have added attribute. It's kind of decoration information. I mean, it's to decorate this property. And let us look what will happen in the property grid. So I added universe. Edit. Okay, it's very troublesome. Edit Gaussian function set. So once the debug point is breakpoint is not if you don't want to edit, just disable it temporarily. So if I click on the Gaussian one, you see the mean and the standard deviation have been grouped within this category. Parameters. So that will make it probably meaningful. Okay, another attribute can be added is so-called description. If user click on this guy, you see there's a box under the property grid, right? Mean, standard deviation. So if you like to add some more information to guide the user, specify the property value for you, then you can add some extra information right here in this box. So that is related to attribute called description. So let us go back to our Gaussian function set, the parameter declaration right here, right? So we add another declaration called description. DESC. Okay. Once IntelliSense highlight this guy for you, you don't need to type the rest of it. It is similar to we create an object of that class. So that will invoke a kind of constructor. So the constructor is kind of function. So once IntelliSense has highlighted this keyboard for us, description, you don't need to type the rest of them. You simply type the left parenthesis, put a string there. So type something, mean value for Gaussian distribution. Anyway, I mean, just help the user get it. So add another description by adding that attribute to this right bracket, and then separate it by semicolon. That will do. So right now, I do add this description for my mean. You see, it's kind of confusing. I need to select one, then this button work. Otherwise, all right. So once the user came to this mean, the description string will show up right here. So help your user, to get familiar with your parameter. Somehow, write more emotion here. Okay, so that's a kind of declaration for the property grid. And if you look into the usage of tree view, later on probably you can add some small image to this label. So if you like, eventually up to assignment 6, our so finally we will have this kind of structure, tree view. We will add another label. We insert the first label into the, we have added 2, but in design phase you should add 2 tree node. The first one, is the text phase is input universe. So user knowing that we try to add a universe to this subnode. So we add a universe, and once user click on X1, then user may specify the point modified set on it. So we keep focus on the universe, right? So user can add another one, bear function. All of them are bear function, right? So try to make some parameter change to see the variation shape of a bear function. So for a bear function, right? So if I click on here, or either way I click on this here, they are highlighted somehow. So this is a bear. Remember, this is a bear function. Why? Take a look at the parameters. Slope 0.2. If I have slope 0.5, if I slope 0.8, why? How about slope is minus? It's okay, but the problem came out from where? It's from your it's actually not come from the function evaluation. It come out from the actual point I added. Okay, this is my bug. Okay, I kind of added a control point, but during this case it is not supposed to be true. So feel free to change that. And in my intention is that try to let this as control point so user can arbitrarily set it. Again, that is an advanced feature. If you are really interested in programming and if you are enthusiastic, you can try to learn how to do it. Somehow. So that is not important. For now, we will let the user specify their parameter value via this property grid. So seeing that we have property, we have you can name the category in Chinese. It's okay, right?
Would you mind before you're going on? Let's see. I got a little problem on the codes. Would you please turn to the tag of the Gaussian? The tag on the Gaussian.
Okay, which one is your computer?
Sorry, I'm on my laptop.
Otherwise,
so
we can share the next time.
If you could demo your code, you just type in.
So back to the Gaussian function, right?
Yes.
So.
And I want to know when we are adding a category, and we're saying that that category, we name the parameters.
This is not the one I have. I'm sorry. I need to go back to here.
Yeah.
Okay. Here.
And I want to know, in the end of this line, why isn't there a semicolon?
Well, as I say, it's a kind of decoration. It is not actually part of the program. So we don't need to use the semicolon. It's not part of the C# programming at all. It's a kind of add-on the information. I mean, for certain kind of, it is purely edited by Microsoft. It is not related to the C# programming language. So we don't need to use the semicolon.
So
it's not a code.
Actually executed.
No, it's not a code. It's not part of your logical code at all. So it's kind of decoration somehow. But again, description is a class. We call it attribute class defined in .NET Framework. So that will add some more information when it is pop up in the user interface. Okay. All right. So it's a property, but actually you can look into. I mean, you can Google it. Probably you can add another attribute somehow. Sometimes if you don't want your standard deviation appear in the proper grid, you can add another. This one we frequently use, browsable. We kind of hide it because we don't want that the user modify somehow. So if we add this browsable false, then you will not see standard deviation pop out in the property grid. See, right now standard deviation has been hidden somewhere. We are not going to let the user interact with it. So, just knowing now will be now. Once you define a property, then actually you can add some attribute to it in order to communicate or interact with the user. Okay, so that is the information we have. Are there any particular problem? So probably right now is about the time we learn a little bit about the layout of our form. Okay. So, well, up to this point, you know each one is called control. That is the terminology used by the Microsoft. And if you look into any formal application, usually we will have what? We will have menu, right? Pull down menu. We have pull down menu, and we also have a tool button. And we also have so-called status bar. So if you want to design your application as a formal application, actually you can try to add something there. So if I add usually I add a what? Manual strip. M, start from M. This is a manual strip. Once you add it, once you drag into the main phone, knowing that main phone is a container, right? Its parent is container. So right now the manual strip is a children control. So right now it has been automatic dock to the top. So check about the relationship between this main phone and your manual strip. So this is the manual strip. The property anchor. Last time we talked about the anchor, right? Anchor. So anchor top level. But dock will override your anchor property. Dock, because right now dock to top, right? So it has been snapped into the top of this or its parent. So this property is always related to its parent, right? So if you won't reset it, you can set it to none. So dock to its parent without any docking. So if you want to dock to the top of the parent, click on this guy, to the left, to the right. So usually, I mean, for a manual strip, we always dock to the top. And another one should be the tool strip. Tool, T-O-O-L, tool strip. So once you drag into your main phone, again, it is docked to. So both of them are docked to their parent. their parent is the main form. And how about the status strip? Status strip. So once you drag it, so it not just shown up within your form, it also shown up right here. So you can click on it and it changes some property of your status strip. Or otherwise, you can add some children control on the status strip. So usually I can add what? Probably I add a standard label. I might add a progress bar, add the rest of them. So you can feel free to try that. And how about the menu strip? Menu strip always start from a menu, right? The top label menu. So usually we have a so-called file. And the second one probably edit. Right? And probably about something. You can always see it's from a formal application. And under this main category, you can type probably open ... It's a convention. If you put a 3 dot there, that means once the user click on this guy, there will be a dialog come out. It's this kind of convention somehow. And probably you can have save. So just feel free to do that. And as you up to this point, you know, well, definitely that should be a control, right? Yes. No problem. It's definitely a control. It also have a standard click event can be subscribed. So almost like a button, right? Yeah, that's right. But it's a little bit different from button, but they always have a click event generated, so you can subscribe it. How about toolbox? Button, you can add a label, add another kind. So just feel free to try it. I mean, later on you might want to design a versatile and really luxury user interface. You can use that. But for now, usually we need to use up the big screen or the user's desktop, right? So between the toolbar and the slide bar, you can try that. This is my habit. I usually drag a split container. Split container actually is a kind of group control. It kind of group 2 panel control within it. Panel is another container. So a panel can host a bunch of low-level control there. So it's a container. So right now I have what? I have a split container. It's called split container 1. This one is a chart, right? So it's a tribute. So all of them are on the same level, okay? So their parent is the form right now. So if I kind of drag my curve into this container, this panel 2. So right now, my chart has been pressed into this panel 2. So if you want to move the control, you can kind of cross once the rubber rectangle intersect with the control, it will be highlighted. So you can move it. So right now, it has been put in the panel 2. So if I keep drag the control there, and probably add here. Once you move it, you see it has been moved into this container. So knowing that the control, some of them play as the container status. So if it is a container, then it can host others control. Again, so right now, this split container has the same hierarchical label with the menu strip, tool strip, and the status strip, right? So these two strip has been docked to the top. This one docked to the bottom, right? So right now I click on this split container, try to dock the rest of the screen. So select this one. All right, so it will look like this one. All right, so once user use your user interface, user can enlarge it and then move their cursor, I don't know where. Okay, right here. It's called splitter, right? So user can arbitrarily, either increase the relevant size width and reduce it. Okay, so it is better that you add some back color in order to distinguish each panel for you to identify it. So feel free to do this kind of changing. Okay. So probably within a split container, you like to add another split container. Fine. So for example, if within this panel one, I add another split container. Let's start from this. Okay, by default, the two panel has been arranged horizontally, right? So if you look into the property of split container 2, you will see another one is called orientation. By default, it's vertical, separate, right? So if I change the orientation, it's probably into horizontal. Then this split container has two vertical aligned panel. So I can initially divide them evenly. So in that case, I can move my cursor in panel 1, try to shrink it, move into the second one, close this guy, enlarge it somehow, this one, move to this place, and finally, you see, right now this split container is a child of this panel, right? So that is the parent. So if I select this one, dock to its parent, the whole space, the rest of them, so it will dock the full screen there. So that is the way we kind of tailor our main phone into different kind of areas. So later on, user, excuse me, let me set another color, set different kind of back color for you in order to know the range of each panel. So right now we have 3 panels, right? So user can feel free to move the splitter there. So within a panel, within a block, then you should identify which one is the most important one. So it will use up the space. So if this guy is more important, right? Yeah, definitely not. So we kind of set up the maxima value, and then we set the anchor property with respect to its parent. We kind of anchor all. If this one does not specify anything, by default it's anchor with respect to the parent by the top and left. So how about this one? We can enlarge it and then set up anchor property. This is the important one. And how about this guy? This is the most important one, is chart, right? So enlarge it with respect to the current layout. So we kind of activate it. Anchor. This guy, maybe around it. And pay attention to that. Once you move, you see there is a guiding line. Blue guiding line came out. Try to let your layout align with other control. So in order to make a good or professional look, you should use this kind of advantage. There is once you move it, you see there is a blue line, guiding line, helping you to arrange the size and the location of your control. All right, so up to this point, we kind of tailor our screen into different kind of categories. So user can feel free to enlarge it. All right, so just keep practice with that. Is there any question about this kind of skill? So just remember that certain kind of control play as a host or a parent. So it can host the child control there, and then usually you should set the anchor property with respect to its parent in order to take advantage of a larger screen somehow. All right, shall we maybe take just 5 minutes break? For you to go to the restroom. and later on we'll come back because we need to step into assignment 4. So is there any particular problem about assignment 3? So assignment 3 you need to, finish this, this part, right? So for assignment 3 we need to complete add the universe, and then so we can specialize primary fuzzy set on it. For the next assignment, we will add the inclusion of the unity operator fuzzy set and binary operator fuzzy set. So that is the mission for the next assignment. So up to this point, you will not just go, it's just similar to the work of Mr. Fong. You will have a list box, for example. You will have a list box here to let the user select a type of fuzzy set and then add that to universe, and then user can later on click on this guy, modify the parameter right here. Okay, that is the goal for your assignment 3. Okay, and you can, if you you can probably Google the information about how to add an image to the tree node of your tree view. Okay, so just let us take a 5 minutes break. If you have any problem on your assignment 3, probably just let me know. I can take a time to check your source code during the break. Okay, so let us take a break. Okay. 是。
就是我刚照你讲的，就是把 category 打上去啊，就是在 property attribute 在 min 前面，
是，
然后它也没有跳错。可是我执行的时候啊，就是当我 create 一个 universe， 然后它是高显的嘛，generate 的时候，我的这个 box 它并不会跳出就是那个 property 的。
看到了。
对。
但是你现在选的是什么？
要点。
不是，你现在选。
对。
哦。
对。那你比较聪明的话，你可以写程式。比如说我加了一个那个 fuzzy set 的时候，我选择的 node
会直接去选，
是那个就把它选下来。也就是说，其实我们人机界面时候，我加了一个 fuzzy set，我马上想要改变它的参数。是。但是你可以因为by default我们现在，你看你去看老师的不太一样哈。我选的是，你去看我现在选的是 universe。当我加了一个高性 fuzzy set 的时候，我这边的 select 我自己跑到那边，对，你是可以程式说，你看，我没有，我是维持在这个地方，我是维持在那，你可以让它就一开始就 highlight 这个家伙，是可以的。就其实你改变，我们是读出这个 tree view 的 selected node，select node 可以读，我也可以改写。就当你加了一个，你产生一个 tree node for 这个那个高线 2的时候，你可以把这个 tree node 设成那个 tree view 的 selected node， 你可以强制用程式写它就会被 highlight 那家，而且会展开这样，可以试试看。
谢谢老师。
不好意思，我想问一下，就是我们现在 little heart 跟 core or heart 交集之后，是不是得到0.5跟0.6两个点？
没错。
那我们是不是应该先取小的？
我们的 projection 是取大的，我们是说有一个 projection 过程，你就是说看那个可能第二章啊，第三个章，我们是一个 projection 的概念。其实它在推理的时候，其实是一个 projection， 就是我得到了一个 fuzzy set， 我把 project 过去，就是我找最大的点。所以我们会将来在 fuzzy set 会有一个方向，你要找到最高的、最大的 membership degree 值。我们是拿最大的值。
可是 course video 里面例题的时候，它公式不是 max， 然后里面挂一个 min， 所以先取 min 再取 max。然后我看例题好像也是这样讲。
可是那个立体的图是说要投影，你要知道就是投影，就是你们觉得我们要投影到这个轴上，所以这个东西投影过去就是你会看到影子是最高的是这个，所以有一个 projection 的概念是在这个地方，所以会最高点。同样的这个最高点会在这个地方，那因为它刚好有凹陷，所以这两个虽然有两个 peak， 可是投影过去的最高的是这个点，所以这个点会被认为是这个 intersection 的这个结果，就是我用我这个 fuzzy 的那个 set， 我来推理你的时候，我是得到的，就是打投影，所以它其实是来自于那个 projection 的概念。你可以理解吗？这个东西投影过去的话，当然是最高点是那个点，所以我们会有找最高点作为这个 antecedent 的那个交集状况，可以这样想，可以是交集状况。
我们再看一下上课。
好 ，OK。Sure.
What do you mean with triangular function does not have condition checking?
Triangular function does not have a condition check, so that means you can try your code by entering a value is larger than 1, So once the user does not knowing the rule, right? So user can special arbitrary value, but in your convention, you must ask the user specify the value, the A value should be smaller than B and smaller than C, right? But the user does not know that. So once you use the specify the wrong value, for example, you can type A equal 10, B maybe 5, C maybe 2. See what happened. You did not got this kind of condition. So I like you guys. So right now, since right now we have 10 to the assignment 3, so you can do that in your parameter setter. So in order to make sure your data integrity is maintained, that is the purpose of our object-oriented technology. Yeah. But in that assignment, you need to check that, not allow the user specify this kind of combination, the value combination. Yeah.
Okay, thank you. 我想问这个为什么要另外设一个 property， 就是他也没有要对它改什么，为什么要另外设一个这个 property 出来？不可以直接在前面那个 area 这边把它设成 property 吗？
好，这 good point。那个就是我们物件导向技术，第一个叫你要记得说，我 data 要 encapsulate 起来。encapsulate 就是我要把它封装起来，好，那中文叫封装。那为什么要封装？我们可以这样想哈，你假如写了一个 data， 你那个 data 可能是我们拿我们例子来讲好了哈。我们例子是说，我们有高兴的发射 set， 那个 triangle 发射 set 出来，你给它初始设得很好，对不对 ？A 一定给它初始 A 一定小于 B， 一定小于 C， 对不对？好，所以一开始使用者 new 出来没错 ，new 出来了。可是万一那个使用者他最后，我看到 A 你的值假如说是1，那个 B 是5，那个 C 是7或8。那使用者假如说我针对我的 A 我要改成20，你就让他改了，你是 public data， 就让他改了。哇，那你的 A 20，那这个是那个5，这个是8，那你画不出三角形出来，对不对？对。所以你的 data 你既然是一个物件，你是个 triangle发射 set， 可是你把那个这个 A B C D 让使用者你把它设成 public data， 对不对？使用者可以高兴乱改啊。那改了之后，你就程式你就乱不出来，你要放就乱出来。我们这叫 data integrity， 你就没办法维持。
可是这个也没有要让他改东西啊。
你 actual area 你哪一个东西？
这一个啊，它不是也没有 set 嘛，它只有 get。
对，那 get 只是让它读取，但是呢，我们好 good point 哈，因为我们现在 C# 的东西其实都是什么？都是所谓参考性别，所以尽管我给你一个 child area。那个 child area 其实这个是跟那个硬体资料，就有空我会再跟大家解释。它其实就拿到一把钥匙，它可以进去 child area 的改东改西，改东改西。虽然我们看到了，好像我只是让它围堵，对啊，对，但是你围堵你给他的是一把钥匙，有点像你家，你不是给我说我家只是在外面参考，你是给我一把钥匙，所以我可以进去里面改这个东西。那这个 child area 只是我们是让它容易拿到而已啦。坦白讲，如果你假如说 create 说啊，那这样我还是可以让它改到的，没错，它其实会被 data 会改到的，那你现在的 question 来，我们再回来，你现在比较 wonder 是说，为什么不把它直接放成 public？ 对，以这个例子来看，没错，似乎你就给了，就直接给他而已嘛，对。那但是呢，我们给他 public 最怕的是说，它能够 set， 它就能够把你整个重新设哦。比如说你变成 public 的时候，现在差别是什么？他拿到你的那个 public 拿到你的资料之后，他可以全部给你 new 一个新的 child area 出来，就别人不知道怎么给你使用的。当你把那个主导权交给他的时候，那我们就怕我们自己的 data 会被那个毁损，所以我们一般不 prefer 我们的 data field 是 public， 我们都是经由 property 把它开放出去给人家围堵，或者开放一个 set， 对方可以来改。但是要透过 set 我来把关，就像我们刚才 A、B、C、D， 我会在那一定会在那把关。你设一个 A 给我200，我是根本不会让你接受。你看你有耐心还是我电脑有耐心？他在 public 改200永远不会成功，因为我们没办法查过，但是透过我们 set 还原过来，所以这是物件导向的一种 paradigm， 一种境界，就是我们希望这样，那才能够好容易除错。要不然说你程式说 public data， 可是我程式到底挂在哪边是谁这个不经验帮我改了，找起来非常难。所以意思是说，一个类别物件导向设计，我的 data 我自己管， 那我自己维持我的 integrity。万一将来程式当掉的时候，那我很容易找就这几个方选再改这个 data， 我就比较容易出错。如果说 data 全部 public， 哇，那这个程式非常复杂，他说你根本不知道谁哪一个类别哪一个什么时候改成这个 data， 要去除就很困难。所以物件导向它有一个 paradigm， 它的意思是说 data 要封装起来。好，那我也透过这种 set 跟 getter 来把关，维持你的 integrity， 将来比较好出错。好，所以慢慢体验了，就是有空的话看一下物件导向他们这些那个技术的说明。那你这个例子还没错，因为我们其实C# 原则上因为都是所谓参照的东西，其实我们都给人家钥匙。坦白讲，虽然它是唯读到这把钥匙，但是它其实是拷贝这个钥匙，它其实透过这个钥匙可以来给到，这是 another story 了。这个要讲的话，我们会花点时间再跟他讲。好。
这样看到，
OK，
就是它这边录的是 x 是 A1， 然后 Y 是 B1， 然后的 Z 是 C1。那它这边 A1 跟 A prompt 交接点是不好意思。
刚才的 A prime 是一个 47 还是一个 constant？A
prime 是一个 constant。
常数字。对，刚才你跟他看那个新闻了，所以它这样的就是变成我们比较简单，我们不用把它当成 47， 因为 47跟47要交集，要得到一个47，知道吗？所以 Christopher value 的时候，我们就直接看它交集点、交接线就可以。
那交接线就是说取大的。
交接线只有一点啊。
可是还有 B 啊。
B 对啊 ，B 是另外一个第二个前项，就是到时候要，因为我们是用 and 起来，条件是说天气啦、温度啊 and 那个这个什么压力要怎样，那这两兆是不同的那个 antecedent 加 and 的话，我们是取小的，我们是取保守的这种 file 的方式，我们也可以其他什么 T弄的做法，但是现在我们是取小。
A1 跟 A prime 交集点是0.8嘛，然后 B prime 跟 B1 交集点是0.5。
然后 A prime 是哪一个
？A prime 是黄色。
是嘛，所以它还是个47，对，47跟那个 你现在是 A1 嘛哈
？0.8。
对 ，A1 它其实是交集的，它是一个47，它还是个47，交集还是个47嘛，交集的47，啊，47最大的值是在一个点，所以它的点是0.8，没错。
然后 B 是交集在0.5。那为什么是要取？
好 ，OK， 我这样来快点。这个就是项跟前项，就是你可以讲这是温度跟压力，对不对？好，那我们其实如果就是都知道这个路，对不对？那如果到底要切多少？那我们用 and 是用保守的，所以用保守用那个 min 的方式，也就是说它得到这个温度或是压力，温度呢得到一个那个 firing strength， 那压力得到 firing strength， 那我们是取小的来切这个东西，我们就是 default 的做法。
那刚刚是因为是在同一张图上，所以才用投影。
这个还是要投影的，你看
这个要怎么投？
你看交集的发射线是不是这一块中间交集这样？对，这一块，交集投影过去是不是？对，这块是最高点。对，交集的话就是挤在一起嘛，它最高值就是0.8。那所以我们现在看好像两条线交集，事实上不是这个概念。它整个推理的概念是说，那个条件在这个地方，这个肯定在这个，那原来路尾然后前向那边，那找到它真正将来运算就是这两个发射线要找那个 intersected 的发射线 intersection 的发射线，那这会再投影过去。再投影过去，那投影过去的概念是说，我 intersection 的发射线呢，交集的发射线，我就找那个值最大的，找值最大的，找值最大的，那最大值就是所谓投影就是要找值最大的，0.8，所以这时候将来我们写成是我们要实做它就会找到一个发射线，你要告诉我它最大的 membership degree 是多少，就是在找投影概念。那正常的都是1点，正常都这个 normality 都是1点，可是你交集之后就不一样，像这个交集就变成矮1减，对，那投影过去之后它最高值，这种叫做那个 binary operator 的发射线，两个发射线去经由一个2元的运算，就是交集或者连集是一个2元运算，运算过之后它还是发射线哦，这还是个发射线，对，那发射线里它的最高值已经不是1了，它已经没有 normality 已经没有维持了，那我们在推理的时候，我们需要知道它最高值是多少。所以将来的方程，我们将来程式时候就要加一个 get maximum degree。那像这个 maximum degree 1点，这1点，但是那个中间去那个什么两个交集差距出来，你就要真的一点一点去找，找最高值。这样就是在模仿投影，这往后我们实做会做到它。但是推理就是那个投影过去的那个最高点。
那个小问题，就是老师上课有时候会说 就是按 Enter
哎，对对。
这两个有什么差？
好，这两个差别哈。如果说我们来看一个程式，这其实 debug 他们逐渐都有这种共识哦，就是说很多的那个 code 的那个开发环境，就两个在做那个做 debug 过程里面哈，比如说看一下。我们看到程式哈，假如说没放，从那个，好，这个按钮，高显哈。好，所以我们正常在除错的时候哈，就是说常见是说，你可能要找到出错的地方嘛哈。好，那出错的地方，那我们通常是按 F10的话，F10等同于这一个侦错的这个指令，不进入函式。就是我碰到函式的时候，我不进入函式。那碰到一条叙述，当然一条一条叙述执行，对不对？那碰到呼叫函式的，我不进入函式，就是那个等于是说他把函式执行完到下一行，这个概念一样。所以碰到函式它不会进去，它不是碰到函式当然就一条一条执行。那碰到函式有一个选项，说你要不要进去一条一条执行。那这个是碰到函式就会进去的 ，F11是碰到函式就会进去。好。
到一列一列的。
对，好，这你看像这个东西不是函式呼叫嘛？那按 F10按 F11都一样，按 F11一样，好，按 F10也是，对不起啊，因为它条件没有了，它这边要选。好，我们讲说选高显。好，就这样过来，好，一行执行。所以这时候它不是函式呼叫，我按 F10，按 F11，好，它还选定一个 universe， 哈，这个就是没有黄本。好。OK， 好，那我们讲 F10、F11其实都一样的，因为它不是碰到函式，这个不是函式，这是一条叙述，这也是叙述，这也是叙述。那这个是右边是函数，是一个建构函式，它有一个建构函式要执行，所以这个时候你就要决定，我到底要 F10就到下一行，就这边都执行完了到下一行，或者是说，因为这边还有很多东西要执行，所以让 F11就进来那边。所以你如果说怀疑你的错来自这个地方，你在这区就要按 F11。就是选那个除错的这一个那个 F11逐步执行。好，你看所以我们也选这个就按 F11就进哪边，因为它碰到函式执行。那你也可以趁这个机会理解一下一个建构函式，说它扭出一个物件来说，它到底执行哪些事情？因为高显 Forty-Set 呢，它其实是子类别，所以我们要准备执行它这个建构函式但是它还有父类别的资料要交代。所以他会先把这个义务拿到的，已经有义务拿到，这个义务已经拿到了这个义务已经资料这个 universe， 然后把它 pass 给父亲的，这个 base 只是一个 keyword， 就是因为它只是子类别，那它要呼叫父类别的这个建构函式，把继承这父类别的那些 data 由父类别的建构函式再把它初始化，分工合作。父类别已经有 data， 父类别有建构函式在做它初始化，我子类别有新的 data， 但是呢，将来要产生子类物件的时候，父类别那边要交代，那我就拿到义务做父类别，我就可以引入父类别，他已经知道义务，他去做他初始化，所以父类别那个资料由父类别的建构函式来引导。好，那我们继续这个又是一个函式，一个建构函式，我们按 F11进来这个地方，来到这个地方，来到这个是境内的高线或者是，那只要碰到有等号的，代表那个 initialization， 这行就会直接执行，那之后再执行这个父类别的建构函式成人后外。所以你看，你是子类别的高线，你也有 universe 就是在这个时候有父类别的建构函式帮你初始化。好，这本来原本进来的 universe， 你现在这个高线的 universe 是空的那现在父类带进来这个就一步一步，这个按 F11也一样，因为不是函数呼叫那所以这个按 F10、按11都可以。那你看这份完成了但是你现在还在这个子类别的建构函式里面，所以一行一行执行。所以这两个只是你真的是要深入到那个函式的下一层去看它程式的内核没错这样。所以 debug 的过程里头就当然可能要做什么，那就思考一下这两个阶段。那如果说已经知道错了，你就可以直接按这个让它继续执行。这个就继续执行，它就碰到中断点才会停，要不然就是进入互动界面跟你互动，然后程序就正常在执行，但是还是在 debug 模式。然后执行下去有碰到中断点还是问题，所以透过 debug 来学，OK， Okay, so if you All right, so we need to step into assignment 4. So probably today we're not be able to complete all the instructions. So never mind, I might take another video shot for the rest of the instruction for the assignment 4. So probably, I mean, I don't know. Let me check about the video viewing schedule. Okay, so probably you will be excused. You will be excused for video viewing somehow, because we need to hold up a little bit, just focus on the fuzzy inference system. Okay, in this moment. All right, so this is assignment 3. So take a look at the instruction of the assignment 4. It is simple. So we try to add unary and a binary operator fuzzy set. Remember that means up to this point, what we implemented the primary fuzzy set. So every primary fuzzy set has a mathematical way to define it, right? So we can draw the membership function according to the equation. But unary or binary operator fuzzy set will depend on the operator first, and then the target fuzzy set, right? So we need to implement that. So so for the assignment, we try to implement the unary and binary operator fuzzy set. What I'm going to instruct you, just focus on unary operator fuzzy set only. So you need to do the binary operator fuzzy set by yourself. That is much more complicated. Well, not actually complicated at all. Once you get the idea or the unary operator fuzzy set, it is not difficult for you to implement the binary operator fuzzy set. Okay. So we try to upgrade our assignment from assignment 3 to assignment 4. So it's about the time. How can we migrate from older version to new version? So I will instruct you to let you get familiar with the solution file and the project file, such kind of thing. So copy the last assignment and rename the solution folder to assignment 4. Okay. So so you see, right now I have my assignment 3, right? So I kind of copied the whole stuff into a new one, and then change the name of the solution folder into 4, right? So it's easier, right? But the file name started with the ASS03 should be changed, right? You see, even though right now I'm working on my new assignment 4, but my solution file is still bearing the number 03. So I like to change the name in order to make the file system means consistent. So copy all the artifacts to a new folder, rename into assignment 4, advance the name, so start reading into assignment 4. So okay, I directly change that solution file, change it into the 4. So what will happen? Once you double click on it, this guy will not be recognized, right? Well, this one is still okay, but again, we like to change the name. So change the project name from assignment 3 to assignment 4, advanced name. So not just the project folder, not just the solution folder. I also upgrade my project folder. This is my project folder into 04, and also the project file. We have a project file, CS project file, right? 03. So I change everything. But once I click on, after the modification, if I click on the solution file, you will see error message came out. Okay, so probably not successfully loaded. So you are not going to open your project anymore. I mean, from the Solution Explorer. See, you cannot look at it. It's okay. You see, since I have changed the project name from 03 into 05, but right now, why this 03 came out? Because my solution my solution definition file still keep that older name, right? So we need to change something. So up to this moment, forget everything. Okay, so we need to manually change something in order to let the file system consistent, file system consistent with each others. Okay, so how can we do that? So the first thing is that probably you can pop out the text editor 笔记本或是小作家 up to you 哈。So you cannot find it, you can just add a text file. So okay, so this is the text editor. Pop up. So the first thing we need to change the content of this solution file. As I mentioned before, well, don't worry about this solution file. Usually don't need to touch it, but in this case, we need to make some modification. So once you open the solution file, well, the target should be 03, so you can use Control F. Again, Control F, it's by default search. No matter what kind of application you are using, probably is a text writer or a programming editor, you can always try Control F. Control F is try to find. So we can find AS03. So change that. So you see, there is a kind of record indicator that within the solution try to deal with project. Project name is 03, right? It's the old one. So we need to change that to 04 because we have changed the name, right? So how about the path? This is subfolder. This is a project folder, right? So change to the 04. And how about the project name 04? I think that's it. So that is the place we need to change. So there is a project name, new project name, excuse me, yeah, that's a project name. And this is project file name 04. It's a project new folder name. So once 03 has been changed, you can save it. So I save it. And how about, well, I think that will be all. And 04 should be okay. Let's take a look at the project file too. So then that's open CS project. Let's see, Control F. Is there any keyword related to SMS? Oh, okay, we have. All right, it's called root namespace 03. Well, it's okay. We could later on we can modify it. So we don't need to do any change. I mean, within this project file. Later on, I will show you how to change that. I mean, via the Visual Studio. Okay, so up to this point, we just change the content of solution file. So try it again. Try to open the solution file again. So up to this point, we change the 04, and then we do make some changes within it. So click on assignment 4 again. Yeah, it's okay right now, right? But as you can see, the original project is 03, right? So take care. Look, this is about the time. Each project has a property can be specified by the user, by the programmer. So let us click on this project. Right-click it. There is a property, or you can search the manual strip. There is a project item there. Similarly, you can pop out the property windows for this project here. So now we have changed our name into 04, right? Our project name. So either way will do. So this information are still the older one, right? Because we copy from the assignment 3. So the assembly name, that meaning what? Meaning you will name the executable file with this name. So initially that's project 03, so that should be 03. So right here we kind of change it. So we like to make our let our executable file name with this proper name. And how about the namespace? So by default, your namespace has been assigned by the Visual Studio. So since your project is 03, so the default namespace is 03. So at this point, we change that 04. Okay, save it. And then go back to your any source code, any class. So you see, previously we have defined our generic fuzzy set, right? But the namespace has been assigned by the project, by the Visual Studio. So the namespace is 03. So in this point, okay, just follow me. Highlight it, right click on it. There is a command called rename, because a lot of place has been using this older namespace, right? So we need to do the renaming, not manually one by one by yourself. We should ask Visual Studio rename this namespace for us. So click on it. It is kind of highlighted in light blue. So type it into 04. Apply it, and you will see. Previously, the namespace is 03 has been completely replaced. So let us check about the Gaussian fuzzy set. You see, has been renamed by Visual Studio. So up to this point, you have successfully transformed your older assembly into a new one. Okay, so remember that what we need to change is the solution file, and after the solution file has been updated, then we come back. We can open that in the Visual Studio and change the Visual Studio there. So once you recompile it, recompile it, you will have a new executable came out. So everything is here. Then click on the project, right click on. If you want to locate the file, there is a shortcut here. I will open your project and then go to the bin debug, right? As you can see, a new executable has been generated here. But remember to delete the older one, not confusing your instructor, okay? All right, so make everything neat in here. So right now, we start from here. We came into the assignment 4 in this moment. All right, just don't feel panic. Just look into the solution file and then change the name and upgrade the name. All right, is there any question up to this point? Do you have any difficulty? All right, so that is not our focus at all. In the assignment 4, we try to add a new fuzzy set, right? So I'm going to show you. Let us take. All right, assignment 4. Okay, so we complete the first step. We migrate into a new project. Okay, analyze the data structure of the one-dimensional fuzzy set and the fuzzy set data resulted from various operations. So basically, there are two kinds of derived fuzzy set, right? Unity operated or binary operated, right? And then within this operator, we have two different kinds of operator. One is called T norm, the other is S norm for binary operation, right? So just go back to the textbook and then see that we try to implement that kind of operated fuzzy set. Right, so we keep on using the object-oriented technology to design our library. So unity operator include negation, right? Negate, and the value cut or value scale. I mean, in fuzzy inferences, we will let the user choose whether it is cut or scale operate. And a linguistic hedge, right? Value, very hot, very hot, extremely hot. Such kind of fuzzy terminology. Actually, that will turn out to be an unity operator. Operate on the fuzzy set. So more or less, it's a dilation, right? Extremely industrial. So these are the unity operator. Unity operator, we will have a unity operator, right? And then also we will need one operator. So that is unity operation on fuzzy set. Okay, so for constructing an operator for this set, the operator must be specified by the user, right? Yeah, similarly. So therefore, you need to define a family of class for this operator. For example, define a class of unity or FS operator, binary FS operator. Notice that an enhanced operator might have parameters specified, right? So go back to the textbook, you will see a bunch of scholar and the expert, they have invent different kind of unity and binary operator, and then usually they have a parameter can be specified by the user. So similar to the fuzzy set, right? Okay, so we start from this point. So we continue with our new assignment by adding the unity operator. So okay, we come back to the project again. Add class. So I call it unity fuzzy set operator. It's a generic operator. We did not define any particular operator at all in this moment. So we like to share this class for other assembly. So we declare that class as public. All right, similar to the fuzzy set, generic fuzzy set, right? Usually we have a parameter. So array. So if it is double and it's a single data, so once it turns out to be an array, and the data type should be a reference type, so we call it. So if the operator does not have any parameter instantiate, fine, just leave it there. By default, it's none. The array is none. So we have parameters, and also we might have a name, right? So usually we will have a name. So start from protected string. We might have a name. The most important thing is that we need to calculate the final value, because an unity operator will work on a fuzzy set. So we will have let me see, do I have any specific instruction or not? No. Unity operator final fuzzy set. Okay, so I did not declare that. So we might implement a negate first. Okay, so we will have a public function, right? And we call it calculate value. And if you give me a value, I will return you a value. Eventually, since there will be no any object instantiated from the unity FS operator, because it's a generic thread, so usually we have a throw new exception. Say no, or probably no implementation exception. And we will declare that as a virtual function, because the inherit operator, I mean particular unity operator file should implement this function, right? Because right now it's kind of generic operator. So we like to declare that each unity fuzzy set operator should implement this function in order to participate in the unity operation. All right, so we have a class defined right here, right? So in order to save the space of a file, so I like to declare a derived class right in this file. So I start from public class called negate. You can name it by yourself, negate fs operator. So we know negate is a unity operator file set, right? So this class will inherit the one we just created, unity operator fuzzy set. Which means that if you have a negate operator instantiated, you will have parameters array ready for you to use, and we also have a name specified, right? So in here we will declare a constructor. There's a secret word, secret code. Once IntelliSense has highlighted this secret word for you, you kind of hit tab key twice. So we just will prepare the constructor for you, the skeleton for you. So a negate fuzzy set operator is fine. Well, since I'm a negate, so I will set my name into negate. probably it is not necessary to name negate 1, negate 2, negate 3 at all. Well, up to this point it's okay. So we prefer negate for this operator. And then we need to override it because we have a, right? So we override, type of override keyword, and then type a blank space character. So IntelliSense will highlight those functions, those virtual functions can be overridden by you, by this derived class for you. So since we have declared category value, right? So we have a category value, right? Category value. So let the IntelliSense highlight this function for you. You don't need to type the function name directly, type the left parenthesis. So invoke it. So by default, it will call base. It will call this function. So if you do not implement it, eventually this function will be called, and then you will get an exception. So your code will be broken, right? So okay, since right now I'm in negate, right? So if you give me an x value, I will return what kind of value? It's simple, right? y+0 minus x. That is the purpose of a negate operator, right? So unit operator receive one value and then return one value back. If it is a binary operator, then this category value should accept two value and return one value back. So that is the purpose of a unity operator. All right, so far we have negate. So the rest of them you should implement by yourself. So we have what? We have concentrate, right? Concentrate and dilation, right? You just look back to the textbook, see how many unity operator has been defined there. You should implement by designing a derived class inherit from the unity operator file set. Okay, so we have unity operator operator ready for us. So it is about the time we extend our generic fuzzy set. So we have a generic fuzzy set right here, right? So the generic fuzzy set. So we are about to define. So we add a new class. We will call it unity ATE operated fuzzy set. Unity operated fuzzy set, right? So we try to model negate a negate fuzzy set, right? Or concentrated fuzzy set. This kind of fuzzy set are derived from a unity operator and a fuzzy set, right? So that is a unity operator fuzzy set. Okay, so similarly we declare the class public unity operator set. What is the relationship between this guy and the generic fuzzy set? You might think that, well, my generic fuzzy set what we have, right? We have parameter universe series, right? Everything is right there. How about a negated fuzzy set? A negated fuzzy set also have this data, right? This kind of data, right? So our unity operator fuzzy set, will inherit from generic fuzzy set. Okay, once you inherit, then red query came out because our generic fuzzy set asks what? Our generic fuzzy set asks that you should provide a universe in order to create a generic fuzzy set, right? Okay, so up to this point, CTOR came out. Again, the red query came out. Right now, we are defining a derived class. And for the parent class, in generic fuzzy set class, let us see how many constructor has been defined there. So constructor, right here, we have one constructor, right? This constructor always asks for a universe ready because a fuzzy set should define on a universe. So that is the one, and I think we should have another one, right? No? Yeah, okay. So the parent asks for a universe. So since I'm a child, I'm a unary operator fuzzy set child, just like the like a Gaussian fuzzy set. Okay, so I will ask the user give me a universe U, and then pass that through the base function call. Base meaning what? Meaning the parent U. So you need to provide this kind of constructor to let the user to let the parent initialize their data somehow. So okay, this one. So we have U and then U, but let us go back to the definition of a unary operator. What kind of data we need? So definitely we need what? We need to have a unary operator. I call it the operator. And also what? And also we need to have a genetic fuzzy set. The operator. I might call it this way, right? Since I'm a unary operator fuzzy set, right? The operation will be determined by this operator, but this operator will be used to operate on this primary fuzzy set, right? So that is the member of a unary operator needed to have. Okay, so unary operator will have an operator and have a generic fuzzy set. So where should we have these two defined? Through the constructor. So I ask the user needs to specify unary operator fuzzy set. OP, I'm going to call it OP. It's not good at all, okay? But never mind. Generic fuzzy set FS, like that, universe U. So then I can easily sign the operator. You design this class. You define your own constructor in order to make your data integrity maintained. So if a user wants to instantiate a unary operator fuzzy set, the user needs to provide you a fuzzy set and an operator, right? That is the whole idea or class design. So the operator equal OP, the operand equal FS fuzzy set. Let me see, unary FS OP. Oh, okay. Yeah, type is doesn't match. Operator, not operand. Sorry. Okay, remember that in designing Gaussian fuzzy set, right? If you take a look at Gaussian fuzzy set inherit from generic fuzzy set, right? So we have our own constructor ready. So we have parameter instantiator, we have a name specified, right? Similarly, so we will add a name mechanism right here. And each derived fuzzy set should implement this function, should override this function, right? Okay, so let us go back to our unary operator fuzzy set. So my naming, similarly, I will add that. I'm not going to say it's a Gaussian fuzzy set. What should I say it? Remember that right now you have an operator, right? So I might put what? The operator dot name. Name is not defined as property, right? So let's go back to the unary fuzzy set operator. We have a name special, right? So we kind of declare a property public string name. That's very simple. Get. I simply return my name for the user. Anyway, I'm a unary operator. I say I have a name property. I will let the user get it. Okay, so name is ready. Then let us go back to our unary operator fuzzy set. So I like to name the name for this unary operator, right? So I will use the operator, capitalize name, and the current count The second one should be the operand is a fuzzy set. Similar, they have a name, right? And how about the counter? Yeah, probably I need a counter for the count. So within this current count, yeah, current count is defined in the Gaussian fuzzy set, right? So I need to have my own count. So fine. So unary operator has its own static data. Keep the counter updated, so I can name it in different name. So I have a name ready here. All right. So similar to the Gaussian fuzzy set, right? So it's about the time I kind of overwrite the get membership degree, the function. Right, okay. So you get a value x, right? So how can you get the membership degree? Problem came from where? Come from the, let me see. Come from the, let me see. Remember that, I mean, oh, I'm sorry, can't do it. Okay, I might spend another 10 minutes. We will end up today's discussion. So at least let me finish this part. So for example, if I have a triangular fuzzy set, right now I try to get a negate. I try to use negate. Try to operate on this triangular. What I will get should be this one, right? Negate the fuzzy set will look this one. So how can you get the member degree? It will depend. Suppose right now I have x. So I need to get the value from the original fuzzy set, right? And then apply the unary operator on this value to get this value. So it's kind of trick, but it's really, I mean, it's straightforward. I mean, once you look into the idea. So I will get what? I will ask the operator get membership degree first, right? And then I apply the operator. So I ask the operator get value. Oh, excuse me. The operator, I did not make it up. Unary, let us go back to unary operator for this. Unary for this operator. Probably calculate value. I'm sorry, calculate the value. Okay. So the operator calculate the value. All right. It's some weird, but just this line will finish the job. Okay, so later on you can, I mean, study that a little bit, and later on. Okay, so I kind of finished the unary operator for this sets operation here. Right, it's almost done, right? Okay, let me go back to our user interface to see if it's working or not. Let me think about operator operand. All right, probably it's okay at this point. All right, so the constructor right here. So up to this point, it's it's still pretty premature, right? So it's okay. So let me go back to the main phone. So yeah, it's about the time. Suppose user click on a fuzzy set, click on a fuzzy set, and then well, you need to rearrange this control, okay, by yourself. So I kind of add button. I kind of fix, I mean, it's hard-coded the stuff there, okay? So suppose the user click fuzzy set, and then click this button. So I was particularly name this one negate. Okay, negate operator fuzzy set. All right, so double click on it. It's full, right? So bottom one, click one. So never mind. So suppose I have get the fuzzy set, genetic fuzzy set. From where? I don't care whether it is Gaussian or triangular at all. I just treat that as a generic fuzzy set FS. From where? From the tree view. I don't. Let me check it. Tree view, right? TRV fuzzy model. TRV fuzzy. Okay. Selected a node. Suppose user to have selected that fuzzy set, and that is real fuzzy set. Okay. So far I did not do any bug checking fuzzy set. So it's an object, right? It's an object. So we know the tag hidden within the tree node is actually fuzzy. Probably is a Gaussian fuzzy set right now, but we would like to cast. So this is a cast. The explain cast. If you want to cast some an object into a different type, you just type the name casted. We call it a cast operation on this tag. Cast it. So we get an FS right now. So about the time we knew an operator, again, that is a genetic operator. Unary, sorry about that, unary fuzzy set operator, OP, new. You see, the variable is declared in the toughest label, but actually we knew negate fuzzy set operator. So once this button is clicked, we will allocate the selected fuzzy set first, and then we new instantiate an object of this unary operator fuzzy set. And it's about the time we generate a unary operator fuzzy set, unary operator fuzzy set. Oops, excuse me. New negate FS. New. Okay, we just finished the constructor, right? So what kind of constructor we need? Oh, okay, you need an operator. You need a fuzzy set. You need the universe. All right, so I will click on the OP, my FS. How about the universe? Unfortunately, I don't think we have a universe, right? We don't have a universe popular out. So universe should definitely, is embedded within this fuzzy set. So we needed to go back to our fuzzy set a little bit. Okay, let us go back to genetic fuzzy set. Try to add that property, because for each genetic fuzzy set, right, we do have a universe there, the universe, but we did not specify any property to let the user read it. So we kind of add a property. It is not shown up public universe. Capitalize the universe. Simply get, just provide getter, and simply return the universe. I said, so it's a public, the universe. But usually we will add an attribute, browsable. False. Okay, and then we just still have us. So we add that property, the unit. So right now up to this point, well, for our usage, we need to supply the universe, right? So we can ask the FS, the universe. But think about that. Actually, we don't need to specify this third argument at all. Okay. Let us go back to universe, the definition. We don't need to specify this guy. But the parent need a universe, right? How can we get a universe? FS dot the universe. It will much more, clear for us to use it. So if you want to instantiate a unary operator fuzzy set, you just provide an operator and a fuzzy set. That's it. And the fuzzy set, because the fuzzy set has published the universe for us, so we can directly pass the universe to the base, to the parent. All right, so up to this point, we don't need to specify the third argument. We just give these two guys, so we have a negated fuzzy set ready for us to use. So similar to your added fuzzy set. So once you add, right? Once you add a fuzzy set, so we have a tree. We will add what? So we will create a tree node, and then tree node tag store our negate fuzzy set, and negate fuzzy set tree node, tree view node, selected node add. I think it's dangerous because we don't know, because the current selection. Okay, you see, what we get FS is that the selected node, we suppose that definitely should be a fuzzy set. So right now, the selected node is a Gaussian, is a fuzzy set, but we needed to say its parent. We need to upgrade one. Later on you will see why this is needed. So tree node, we needed to specify the name. That is one. Show curve, okay. So we like to copy out the curves, right? So this is a guy, this is a fuzzy set. We just created. So that's it, properly. That will do. So we add a universe, right? We add a Gaussian fuzzy set. So we kind of click on this guy. Make sure you click on this guy, and negate can be applied. So we have a Gaussian fuzzy set negated. So step by step, see what will happen. So we will fuzzy set get it, right? Start from the selected node. It's a Gaussian one, so we get it, FF. So FF is to, oh, okay, do not have a two string. We have operator created. Then we are about to create a unary operator fuzzy, so we enter it. We press F11 key, came to here. So always start from the, let me check about, oops. Add a universe. Add a Gaussian fuzzy set. All right, negate. Okay. So I don't know. Did you add a tag? Yeah. Okay. OP. Okay. The universe. Exception happened. Oh, okay. You see, the type is a typo. I should return the lower cases. All right. That is above. Create universe. Add a Gaussian fuzzy set. Add Gaussian fuzzy set. Click on this Gaussian fuzzy set, and then click on negate. So we are about to construct. See, construct. So line by line, the parents constructor, then children's constructor. So it's the time we assign operator, the time we assign the fuzzy set. We will name it. So this is our name. Negate Gaussian 1. Okay, 1, perfect. So constructed, we have successfully constructed negate fuzzy set, and we add the T node similar to the one we added Gaussian fuzzy set. Tag tree. Okay, let me finish it. Edit. You will see the negate fuzzy set came out. Okay, so it's about the time we end up today's lab. So later on, I will keep shooting the video to complete the rest of them. Okay, so you can follow. So not just this one. Okay, so because this student has a triangular, so if I add a triangular fuzzy set, needed to select this guy, right? And a triangular Faraday set. So right now I have what? I have a Gaussian, I have a negated Gaussian, I have a triangular, and then I select this select this Faraday set. Click on the negate. Disable this breakpoint. You go, okay, I have another one, right? I have another negate triangular Faraday set. But the problem, you see, if I kind of change the parameter, triangular one, I kind of shift the peak from 5 to 8, right, from 10 to 12. What about the negate one? Negate one still remain there, right? So what will happen? That means this unity operator Faraday set depend on a primary Faraday set, right? If that primary Faraday set have parameter change, I needed to subscribe the event to update my point. Later on, I will show you how to do that. Okay, I'm sorry about the overtime. Okay, but just bear me with that a little bit. Sorry. Okay, that will be all for today. All right. So if you have still any problems, just email to me, or otherwise drop by my office. 好，我们今天到这边OK， 好吧，那我们剩下部分老师会再拍一个 video capture 上去。
老师，那你新拍的 video 会包含今天的东西吗？
我希望他有录下来，我看一下，我确认一下，因为
没有录下来，我做不出来。
好了，有了，应该有。